Hello everyone, I hope you're doing really well. I hope that you had a chance to review and enjoyed the articles that you read over the past 2 weeks. What we're going to do now is we're going to move on. If you remember, the last thing we did in class is we just wrapped up the types of reactions and you had several quizzes and we were about to have a test on them. So what we decided is you will not have a formal test on Chapter 8 since you already had several quizzes on that. We are going to move on to quantifying reactions. And the way I'm going to begin going over that with you is through ChemThink. Unfortunately, you can't use this ChemThink unless you use Windows Explorer on a desktop. Then you can walk through the tutorial yourself. But since I can't just have you do it on the iPad, I'm going to walk you through it. And I really like this simulation because it's going to help you visualize what balancing a reaction really means. And at the end of this tutorial, I'm going to ask 2 questions. So I want to make sure that you watch the video, so be ready to answer those 2 questions at the end of the tutorial. All right, so here we go. We're going to look at this. We have 2 reactants. And then we're going to take a picture of those 2 reactants and we're going to get some product here. All right, so we have our reactants and our products, and if you recall, they're coming together, so that you would probably call is a synthesis reaction. Here we have one compound breaking up into 2 different compounds, so we have a decomposition reaction, reactants, 1 reactant, 2 products. All right, moving on, we have 2 different types of reactants. We have this type of reactant here and this reactant here. All right, so let's see what they do. All right, so they rearrange and become 2 different types of product. All right, so now we have a single replacement reaction. All right, and we can review this. We have a bond is being formed, a bond is being broken, and bonds are being broken and formed. All right, and let's take a look at naming them. This would be called iron. We're going to call this sulfur, right? And so our product is going to be iron sulfide. Here we have the reactant calcium carbonate, which becomes calcium oxide and carbon dioxide. And here you have 2 reactants. Hydrochloric acid plus magnesium yields hydrogen gas. It's diatomic, so that's going to tell us it's a gas. And magnesium chloride. Okay, we're just going to go through these because you already understand types of reactions. Let's just take a look at this. We have hydrogen and oxygen. What are they going to form? Well, in this picture we have water plus oxygen, but that's not really how the reaction takes place. Hydrogen and oxygen come together to form just water. They don't have a byproduct of oxygen. So let's do that reaction again. We have hydrogen and oxygen coming together to form water again. So how is this different? Well, we wanted the same amount of elements in the reactants and the same amount of elements in the products. So taking a look at this, we have 4 hydrogen, and you can count them, 1, 2, 3, 4, 2 diatomic molecules, 2 oxygen, 1 diatomic molecule, 2 waters, right? 2 hydrogen and an oxygen, and then another 2 hydrogen and oxygen in a molecule. All right, and here you can see they counted the elements for you. They counted the reactants, 4 hydrogen atoms, 2 oxygen atoms. They counted the products for you, 4 hydrogen atoms and 2 oxygen atoms. Now here's a great visualization to help you understand how you're balancing reactions. You see you have a picture of a balance here, and you can see that the copper and the oxygen have a greater mass than this copper oxide. Well, why is that? Here we have 1 copper, 2 oxygen atoms. Here we only have 1 copper and 1 oxygen atom. So what we're going to do is get this to balance out. Okay, we're going to add another copper oxide, right? But then this side is too heavy because we have 2 copper on the product side and 1 copper on the reactant side. So here's what we're going to do. We're going to add another copper on the reactant side. So now we have 2 copper and 2 copper, 2 oxygen and 2 oxygen. We have the same number of each atom on both sides of the reaction, on both sides of the arrow. All right, we're going to do the same thing with this reaction here. We have 1 CH4, 1 oxygen, 1 water, and 1 carbon dioxide. So what's missing? All right, we're going to do this ourselves. 1 carbon here, 1 carbon there. So that's fine. 4 hydrogen, but there's only 2 hydrogen on this side. But before we fix that, let's take a look at the oxygen. We have 1 oxygen, and we have 2 oxygen, so that makes 3, but here we only have 2. So we could either fix the hydrogen first, or we can fix the oxygen first. Let's start with the hydrogen. We have to add water. Okay, now we have 4 hydrogen and 4 hydrogen. How many oxygen do we have? We have 2 plus 2, that makes 4 oxygen on this side, which means we're going to need another oxygen molecule on this side, right? So see how the balance occurs. We have 1 carbon and 1 carbon, 4 hydrogen here, right here, attached to the carbon, 4 hydrogen attached to the water, 4 oxygen, 2 separate diatomic molecules, and we have 4 oxygen on the product side, 2 in the water and 2 in the carbon dioxide. All right, so here we have nitrogen plus hydrogen yields ammonia. All right, and you can see right away that there's 2 nitrogen in the reactant side, but only 1 nitrogen in the product side. So we're going to add more. All right, so now we have too much on this side. Well, we have the right number of nitrogen. What about the hydrogen? We have 6 hydrogen, 2 times 3. We have 2 molecules of ammonia. So you have 3 hydrogen here and 3 hydrogen here. So we need 6 hydrogen on both sides. Here we only have 2, 1 molecule, 1 diatomic molecule. So let's add a couple more hydrogen. Now we have 4. Now we have 6. All right, so now the reaction is balanced. All right, let's take a look at this one. This time we're going to count the atoms. All right, we're going to use an arrow to count the atoms. We have 1 potassium atom on each side. We have 1 chlorine atom on each side, but we have 3 oxygen in the reactants and 2 oxygen in the products. Now we have an odd number and an even number, so that's going to be a clue that we're going to actually cross multiply those numbers. So we're going to take the 3 as a coefficient in front of this oxygen. And we're going to take the 2 that was there as a coefficient in front of this potassium chlorate. So now we have 6 oxygen atoms, but because we put a 2 in front of this potassium chlorate, we now have 2 chlorine on this side, but we only have 1 chlorine on this side. So I'm going to increase the chlorine on the product side, right? So I put the coefficient of 2 in front of the potassium chloride, and now I have the same number of atoms, every single type of atom on both sides. 2 potassium, 2 chlorine, and 6 oxygen. Let's do the same thing again. Let's use some arrows here. We're going to take this aluminum oxide and we're going to fix it. We have 3 oxygen as a product and 2 oxygen atoms as the reactant. I'm going to start with those because I have an odd and an even number. That's just a little trick. So that tells me I do need to at least get an even number of oxygen here. So that's going to make a 6 on this side, and I'll put a 2 on this side. So 2 times 3 makes 6 oxygen atoms, and 3 times 2 makes 6 oxygen atoms on the reactant side. So we're good except for the aluminum. So now we change the aluminum. Now we have 2 times 2. We have 4 aluminum atoms in the product. We need 4 aluminum atoms in the reactant. So everything is balanced. 4 aluminum atoms, 6 oxygen atoms, and 6 oxygen atoms. All right. So take a look at this. Let me back up a little bit so you can read this. Chemical reactions involve breaking bonds, making bonds, or both. Chemical reactions can rearrange the bonds that are present, but there must always be the same atoms present before and after the reactions. This is called the law of conservation of mass. If you know what atoms or molecules are present before and after reaction, you can balance the reaction and find out exactly how many of each product, and each reactant must be present. To balance the chemical equation, you change the coefficients in front of each atom or molecule until there are the same number of each type of atom before and after the reaction. All right, so here's your 2 quiz questions. First quiz question, and you can write this down. What law is being obeyed when we balance a reaction? Okay, and you can see it on the screen, so that's a pretty good hint. The second question is, what are some ways we visualized counting and comparing the number of elements? What are some visual cues that we used using this ChemThink tutorial? So you want to write down at least 2 of them. All right, and I will be looking for your answer on Classroom.